E equals mc squared. Though relativity asserts Earth gravity as the manipulating force for mass increase due to acceleration, it lacks the performance to the lack of mass itself in spacefield space travel. Quanta physics perspective shows that there is a subtraction element to E equals mc squared in space maneuvering while in space. The two elements involve the first Earth gravitation but also a subtraction clause to low-density fields, zero-point energy fields. Gravity, which is explained as manipulating energy, the moving mass doesn't explain a moving mass in the lack of gravity. The single E equals mc squared equation do not explain the full scenario. Big G, little g equations. The big G is based on the same suffix as the little g equation, where in fact they don't. They are opposite scientific equivalence equations. It is this analogy that optimizes relativity into an unfinished work, as it is the hope that quantum physics theory perspective will join theoretical physics into better standard physics theory. While Albert Einstein is famously known for the mass-energy equivalence formula E equals mc squared, the concept of mass itself predates him. Isaac Newton, in his Principia, defined mass as the quantity of matter arising from density and bulk, distinguishing it from weight. Furthermore, the idea of mass-energy equivalence, though not in the exact form of E equals mc squared, was explored by others before Einstein, including Henri Poincaré and Olinto de Pretto. Here's a more detailed look. Newton's contribution. In 1686, Newton defined mass in his Principia as the measure of matter based on its density and bulk, and he clearly differentiated it from weight. Early explorations of mass-energy equivalence. Olinto de Pretto. In 1904, de Pretto published a paper suggesting that the potential energy of a moving particle could be expressed as mv squared, linking it to the mass of a particle vibrating at the speed of light. Henri Poincaré in 1900 also discussed the relationship between energy and mass, particularly in the context of electromagnetic phenomena, though not in the same concise E equals mc squared form. Friedrich Hasenöhrl. In 1904, Hasenöhrl derived an equation E equals 3/8 mc squared relating energy and mass, though his work is noted for some differences and potential oversights compared to Einstein's. Einstein's breakthrough. While others explored the relationship between mass and energy, Einstein's 1905 paper on special relativity provided a more complete and accurate understanding of the mass-energy equivalence, culminating in the famous E equals mc squared. He also demonstrated how this relationship is connected to the conservation of momentum and the behavior of systems emitting radiation. In essence, while Einstein's E equals mc squared is a cornerstone of modern physics, the concept of mass, and the early explorations of its relationship with energy, were developed by earlier scientists like Newton, Poincaré, and others, according to physics journals and physics forums.
Exotic matter, typically defined by negative mass or negative energy density, is a hypothetical concept that, within the framework of general relativity, violates standard energy conditions such as the weak energy condition and the null energy condition. Such matter would exhibit highly counterintuitive properties. For instance, an object with negative inertial mass would accelerate in the opposite direction to an applied non-gravitational force. Furthermore, the gravitational interactions involving negative mass are peculiar. A positive mass would attract both other positive masses and negative masses, while a negative mass would repel both other negative masses and positive masses. This leads to a runaway motion when positive and negative masses interact gravitationally. The theoretical necessity of negative energy density is particularly pronounced in the conceptualization of traversable wormholes and warp drives, such as the Alcubierre drive. These theoretical constructs require negative energy density to maintain the stability of space-time distortions against gravitational collapse. While the mathematical framework of Einstein's field equations allows for these solutions, their physical realization is generally considered impossible without the existence of macroscopic quantities of negative energy. As one analysis notes, the math allows it, but we don't know if the x needed for our y actually exists. The Casimir effect provides a localized, small-scale example of pseudo-negative pressure density, offering some experimental ties to the concept of negative energy. However, the magnitude of this effect is currently far too small to be relevant for warp drive applications. The prevailing theoretical requirement for exotic matter, or negative energy, in space-time manipulation might not imply that such matter must exist as an external distinct entity. Instead, it could suggest that our current understanding of spacetime's fundamental intrinsic properties is incomplete or maybe even mischaracterized. If the zero empty space field grid is the fundamental reality, then the desired spacetime distortions, such as the contraction of space ahead and expansion behind for warp drives, might arise from manipulating the inherent intrinsic properties of the grid itself, rather than requiring the introduction of hypothetical external exotic matter. This perspective posits that the pushing or repulsive effects needed for warp drives could be an inherent manipulable aspect of the grid's dynamics, kind of like altering its stiffness density or pressure. The energy requirements for warp drives are formidable. And honestly, the need for macroscopic negative energy seems insurmountable with current technology. However, the concept of quantum vacuum engineering suggests that the vacuum itself contains vast, potentially extractable energy. If this vacuum is indeed the zero empty space field grid, then, understanding and controlling its fundamental properties could potentially achieve spacetime distortions. This really shifts the focus of advanced propulsion research from the search for exotic matter to the profound challenge of understanding and controlling the fundamental fabric of reality itself. It proposes that empty space could actually be the source of propulsion, which, honestly, removes the need for hypothetical negative mass and opens a whole new frontier for advanced spaceflight based on vacuum matter interactions. This aligns with recent theoretical claims that subliminal, spherically symmetric warp drive spacetimes could, in principle, be constructed based on physical principles presently known to humanity, specifically those involving positive energy. This suggests that the grid might in fact offer pathways that avoid the negative energy constraint entirely.